Hey Dragons, yesterday we learned the explicit formula for an arithmetic sequence. It was a sub n equals a sub 1 plus quantity n minus 1 times d, where n is the term desired. A sub 1 is the first term in the sequence, and d is the common difference. We also learned that the common difference is the slope and the rate of change, and that kind of tied it back into the old y equals mx plus b. Today, we're going to continue using your textbook, so you need to be on page 166. So if you don't have page 166, go ahead and pause it and get your page 166. We're going to look at another way of writing this formula, and it's going to be on your test, so we need to learn how to do it. All right, so from yesterday we learned that the first term in this sequence is a 7. Now, on your paper, what I want you to do is I want you to come over here and I want you to make a table, an input-output table, so that we can kind of start tying it into stuff that we know. We know that this is x and y in function notation, f of x takes the place of y. But you notice up here we don't use x's, we use n's. So if n is my stage or the position of the number, then I have a function of n. All right, so for this right here, the first input, the first stage, gives me an output of 7. So if I make a table, it would look like this. And so if you use function notation, the function of the first stage gives me 7, and that's indicated in my table. So this one, the second, would give me an output of 10, so that would be 2, 10. The third stage would give me an output of 13. Now at this point, if all of this stuff over here is kind of making your head spin, look over here. Look what's happening. Got a pretty neat pattern right here. It's going up by 1. What's happening over here? Looks like we're going up by 3. So if we're asked to fill in the blanks here, continuing with the pattern, I'm going to add 3 each time. So 13 plus 3 is 16. Add 3 to get the next term. That would be 19. Add 3 to the next one, and we get 22. And again, if we wanted to add this into our table, stage 4 gives me an output of 16. Stage 5 gives me an output of 19. And stage 6 gives me an output of 22. So I hope you can see this notation over here is really just an input-output table written a different way. So what is the nth term of the sequence? Okay, let's go back to our formula that we learned yesterday, and let's use that, because that'll give me the nth term. So I'm going to start off with a sub n. Again, this is the formula I ask you to memorize. What do we start with? What's our first term? If we look up here, our first term is 7. And then we're going to add 1 less than n times my common difference. What am I changing by? My common difference is 3. Okay? So if I go ahead and clean this up and distribute, I get 7 plus 3n minus 3. 7 minus 3 is 4. I get 3n plus 4. Okay? So what function could be used? This is just kind of a trick question. Not a trick question. I really don't need to worry about this. I'm going to take this right here and use function notation. So I'm going to say f a function of n is equal to the very same thing I already found. Because it hasn't changed, has it? So we're just now writing it in function notation. So what is the common difference of the sequence? Well, the common difference is the slope, so we can say 3. How is the common difference related to the function you wrote in item 3? Well, 3 is the coefficient of the variable n. Okay? So, go ahead and pause the video. Go ahead and try to do problems 8, 9, and 10 plus 11 on page 167. and then come back and see if you did it right. All right, you try them, or are you just letting the video run? All right, here we go. Again, the function at the first stage. Well, what's the first stage? It looks like -5. So let's write -5. What's the function at the fourth stage? Well, 1, 2, 3, 4. Looks like it's 13. Okay? So, write a function to describe the sequence. You remember what we did in the previous example? Or the previous problems? Okay. We started, we could make a table if we wanted to, a function table. I mean, you don't have to. The first one is going to be a -5. The second one is a 1. The third one is a 7. The fourth one is 13. That's just my sequence position and the sequence number. All right, so what are we starting with? We're starting with a -5. And we're going to add the quantity n-1 times the common difference. Well, how are these guys changing? Well, from 1 to 7, that's a +6, isn't it? And from 7 to 13, that's a +6. And you go back and check that, that's a +6. My common difference is 6. Oops. Hope I didn't cut that off. There it is. All right, if we clean that up, distribute the n, and all of this stuff, we get 6n minus 11. Okay, you can check that. I didn't show all the work right there. It's 6n minus 11. How can you check? Take your 6n minus 11, throw it in your calculator, go to your table and see if these four ordered pairs show up. I bet they do. So now, if we're going to use this function to find f of 14, all we have to do now is take 6 and multiply it by 14, because that's what it says to do right here, and then subtract 11. Use your calculator, you should get 73. At least I hope you do. All right? All right, page 168. In a sequence, the term before f of n is a sub n, or equals a sub n, is the function of n minus 1 is equal to a sub n minus 1. Now, I don't know about y'all, but when I take a look at that, my head hurts. Okay, let me see if I can't explain this a little better. Okay, so if we have a number, a position n minus 1 is the one before it. Well, let's take a look at it over here. Okay, so in our toothpick problem, the first picture way back when had 8 toothpicks. The second picture had 14, but I want you to look at it in terms of the stage before it. 14 is all of the toothpicks from the first stage, which happened to be 8, and then the common difference of 6. All the toothpicks in stage 3 could be found by taking all of the toothpicks from stage 2, the one before stage 3, and adding a common difference. And that's the same thing that happens to all of these. If you want to find the number of toothpicks in the stage before it, or the stage after it, all you have to do is take the stage before it and add a common difference. If you want to go backwards, you're going to subtract the common difference. So if I knew the fourth stage, but I wanted to know the third, all I would do is take away 6. Take away 6 from 26, and you get 20. If I want to find the one in front of that, take away 6, and I'd find 14. So you see right here we have the patterns that we had from the very beginning, but now we rewrite them. We rewrite stage 2 using the stage in front of it, plus 6. Stage 3 is stage 2, plus 6. Stage 4 is stage 3, plus 6. That's all this stuff up here is saying. Look at the one right next to it and either add or subtract your common difference, and that's what you have. So how would we answer this one? For any value of n, how can you find the value of f of quantity n minus 1 equals all that stuff you see right there. What are we going to do? Well, all we're going to do is we're going to subtract the common difference. From whatever term you're looking for, a sub n. Now, I know at this stage right here, when I first looked at this, again, my head was spinning. Yours probably is too. Hang on. Look at the next video. I promise you we're going to look at some actual problems like this, and you're going to see, it's not going to be that bad.